Hi, I'm Micaiah, co-founder of Txtx, and in this video, I'm going to demonstrate how we can make a runbook that can deploy a contract to Ethereum and to any Ethereum compatible chains like Optimism. So in this runbook here, I have this runbook called deploy, and we are declaring this add-on EVM. Txtx does support other blockchains, and so here we say the blockchain we want to use is EVM, and then any of the values we set in here are available to use throughout this runbook. They're automatically used, actually. And so here we're setting up a chain ID, and we're saying it's equal to the chain ID set in the flow that's running, and the same for the RPC API URL. And we'll get into the flow some more later, but if we keep going, we have a signer, and we're naming that signer deployer. And the type of signer we're using is this secret key signer. This is the simplest way to do things. We'll get into some other signer types later, but to use this, we can just set the mnemonic or the secret key directly. And we're pulling this from our inputs. These inputs can either come from the CLI command that you run, so you can pass in inputs, or it comes from this txtx YAML. This is our runbook manifest where we have some environment variables, and we can pull from those inputs that way. And then the main action we're doing here is to deploy a contract using create2. So we call an action, we name this action deploy simple storage so we can reference its outputs later, and then we say we're going to use the EVM deploy contract create2 action. From here, we need the contract assets we're deploying, so we can just get them from this Foundry project using this function, EVM get contract from Foundry project, and then we pass in the function, the contract name that we're deploying. And then we can say who's going to be signing the transaction. We have the signer that we've made, so we'll reference that. And then we can also have a salt that's used to generate the contract address since we are deploying with create2 here. Finally, we can output some data, so we're going to output the contract address. So what we'll do is we'll just set the value of this output to the action name, deploy simple storage, and then the contract address output. All of these constructs and commands are documented at docs.txtx.sh. So we have actions, we can go to deploy contract create2, and we can see all of the inputs that you can set, as well as the outputs that are available, and an example of the usage. And we also have documentation for the signers and all the helper functions you'd want to use for deploying and operating on the EVM compatible chains using txtx. So if we want to run this, we'll just do txtx run deploy. That's the name of our runbook. We're going to do this in the unsupervised mode. So it's just going to run in the CLI. While that's going, one thing I can note is we've set this runbook to have a state. We just say it's the location of a state file. And so now txtx is going to manage the state of your deployments for you. So if I just run this again, we'll see we've already deployed this. There's no changes to the underlying contract, so there's no action here. Now we can get to these flows. So I can declare any number of flows, and that will execute the rest of this runbook once for every one of these flows. So currently I've got a flow called mainnet. I'm setting the chain ID to the mainnet chain ID 1, and I'm getting the RPC URL for a mainnet RPC. If I want to deploy to another EVM compatible chain like Optimism, I can just add another flow. So I'm calling this one OP, got Optimism's chain ID, and I've got a RPC URL for Optimism, and I run this again. Txtx can see that there's a change in your runbook since you last ran, and we can see we've got a new chain to synchronize. We can say yes, and now we're also deploying all of this to Optimism as well. We can add any number of flows to deploy to any EVM compatible chains just with this same method. And now, for the sake of time, I won't demonstrate this now, but if we go and we make some change to our contract, once again, txtx will be able to detect that, and we'll have a similar output here where we can show this is what has changed in your contract, and so these actions will be redeployed for mainnet and for Optimism. We can also use txtx for operating on our smart contracts. So I have another contract here, the same contract, but I have a different runbook, and this time I'm creating a signer, calling it caller because we're going to do a contract call, and it's a web wallet this time. So we're going to be able to run this in a supervised execution mode where we can see all of the actions we're going to take step by step, and we can sign these transactions with our browser wallet instead of having to manage our mnemonic or a secret key and copy and paste our keys. With txtx, none of your deployments and operations you don't need to copy and paste your keys because you can use this web wallet. So this time we're going to just run this on Optimism. We have set up our EVM add-on. We have our contract, and we are going to have some editable values that you can update live as you're running this supervised execution. And then we're going to do an ETH call to retrieve the value from storage before. We will make a contract call to store a new value, And then we will, again, make an ETH call after to get the value after, and then we can output those values before and after. So here, if I run txtx run call, so now I'm hosting this on localhost 8488. If I go here, we have the supervised UI where we can verify that we've connected the correct wallet. We can verify we have enough balance here. We start our runbook and we will see all of those inputs we set up. We can change live what number, since we set that field to editable. We can say the number we want to store is 55. We can validate all of our inputs. We can see the contract address that we're going to be calling. And we can see this is the actual transaction we're going to be signing. So we can check the nonce, transaction cost, and then we can actually sign the transaction here. MetaMask pops up. We can confirm, validate, just wait for that to be mined. And there our runbook execution is complete, and we can see the number that's stored before and after. So now we've used Txtx to deploy a contract on mainnet and on Optimism, and then we've done a contract call signing that with a web wallet, all with Txtx runbooks.